The objective of this topic is to give you an overview of the flux cord arc welding process, equipment, and applications, and to highlight the differences between flux cord arc welding and gas metal arc welding.
Flux cord arc welding is normally used to join thicker materials and is limited to ferrous metals and nickel-based alloys such as carbon steels and stainless steels. FCAW is used extensively in shipbuilding and in construction and heavy equipment manufacturing because it combines the deep penetration characteristics and versatility of shielded metal arc welding with the high deposition rates and fast travel speeds associated with gas metal arc welding. It's also commonly used for hard-facing applications, such as the contact surfaces of excavating equipment to protect against abrasion.
FCAW is very similar to gas metal arc welding. It uses the same type of constant voltage power source as GMAW. It produces fusion by creating an arc between a continuously fed consumable electrode and the work. And it uses a gun and wire feeder to deliver electrode wire to the arc, just like gas metal arc welding.
In this module, we'll concentrate on the differences between flux cord arc welding and gas metal arc welding. These include the use of tubular electrodes instead of solid wire, the type of drive rolls required for tubular wire, the type and size of the guns used for FCAW, the differences in joint design due to the deep penetration and high deposition characteristics associated with FCAW, and the thickness of the material that can be joined. We'll also look briefly at metal cord wire, which is similar in construction to flux cord electrodes.
Flux cord arc welding was first introduced in the 1950s. It combines the slag and shielding characteristics of shielded metal arc welding with the process efficiency and high deposition associated with gas metal arc welding.
FCAW is most commonly used for semi-automatic welding, where the machine feeds the wire and the welder manipulates the gun. It can also be used for machine welding and for automatic applications.
Electrodes for FCAW are tubular and range in size from 30 thousandths of an inch, or 0.8 millimeters, up to 5/32 of an inch, or 3.9 millimeters. With larger diameter electrodes, FCAW is normally limited to the flat position and horizontal fillet welds, due to the fluid nature of the puddle. But it can also be used in the vertical and overhead positions, depending on the contents of the powdered core, the diameter of the electrode wire, and the type of shielding used.
Flux cord electrodes consist of a strip of mild steel or other metal formed around a core of powdered materials. The powdered core is made up of alloying elements that affect the chemical and mechanical properties of the weld metal, along with slag and shielding gas formers, as well as deoxidizers, scavengers, and arc stabilizers. The ability to formulate the contents of the core to meet specific chemical and mechanical requirements makes FCAW more versatile than solid wire.
Electrodes are divided into two major categories: self-shielded and gas-shielded. Self-shielded electrodes contain gas formers that produce all the necessary CO2 shielding gas required to protect the arc and puddle. They're used primarily in outdoor applications where auxiliary shielding gas would be impractical and where breezes might interfere with gas coverage.
Gas-shielded electrodes require auxiliary shielding to protect the arc and puddle. They produce less smoke and result in higher yield strength than self-shielded wire. Some gas-shielded electrodes are designed for use with 100% carbon dioxide. CO2 is the least expensive gas and produces deep penetration. Some are designed for use with a mixture of argon and CO2, and some electrodes can be used with 100% CO2 or mixed gas, depending on the application. A mixture of argon and CO2 produces a spray transfer with less spatter than 100% CO2. Argon CO2, along with smaller diameter electrodes, is used for out-of-position welding.
Electrodes designed for use with shielding gas, with only a few exceptions, operate on direct current electrode positive. DCEP produces deeper penetration than DCEN. The majority of self-shielded electrodes run on direct current electrode negative. DCEN produces shallower penetration, higher deposition rates, and faster travel speeds. Both self-shielded and gas-shielded electrodes produce a slag coating over the weld that must be cleaned away.
Metal cord electrodes are gas-shielded tubular electrodes. Metal cord wire produces no slag at all. That's because the core of the electrode consists of iron powder with trace amounts of deoxidizers and arc stabilizers. Metal cord wires are commonly used in gas metal arc welding for high production applications, such as those found in the auto industry. But they're also used in place of flux cord electrodes due to their low fume generation rates, higher deposition efficiencies, and excellent penetration characteristics.
Metal cord electrodes are confined to the flat position and horizontal fillet welds due to the fluidity of the puddle. But they produce between 10 and 30% higher deposition than solid wire at the same amperage. They require no interpass cleaning because they produce no slag and very little spatter, and they produce very low fume levels compared to conventional flux cord wires.
Conventional drive rolls used for solid wire electrodes could easily crush tubular wire. So drive rolls for flux cord electrodes have knurled surfaces designed to grip the wire and push it through the gun cable with minimal downward pressure.
Guns for FCAW are designed for gas-shielded and self-shielded applications. Most guns are air-cooled. However, water-cooled guns are used for applications involving higher amperage and longer duty cycles. Guns for gas-shielded wire are equipped with nozzles to direct the flow of shielding gas. Guns may also be equipped with fume extractors to remove excess smoke and fumes, although extractors can interfere with gas coverage in some applications. Heat shields, like the one on this gun for self-shielded wire, help to protect you from the heat generated by the process.
Most self-shielded tubular wires require a specific amount of electrode extension in order to work properly. That's because the shielding and fluxing elements in the core require preheating. So guns for self-shielded wire are often equipped with insulated guide tubes that support the electrode and ensure the required amount of extension. Guide tubes come in different sizes to suit the extension requirements of different self-shielded electrodes.
Joint design is a critical aspect of any weldment, and joint designers are very careful about matching joint design to the welding process, strength requirements, and the type and thickness of material. They also take joint accessibility and welding position into consideration. FCAW is a hot, deep penetrating, high deposition process, so joints can be designed with narrower root openings and thicker root faces. This means less area to fill, which translates into less time and money.
Designers also take into consideration whether the electrode wire is self-shielded or gas-shielded. Guns for self-shielded wire don't need nozzles, so joints designed for self-shielded wire can have narrower groove angles. But guns for gas-shielded wire have nozzles to direct the flow of shielding gas. So groove angles are designed to accommodate the nozzle and allow access to the root of the joint without excessive stick-out, which may cause problems with porosity due to lack of shielding.
Plain carbon steel, up to 1/4 inch, can be joined without bevels due to the deep penetration associated with FCAW. These joints are the most economical because they take the least amount of time to prepare, and they require the least amount of filler. On base metals thicker than 1/4 inch, single V-grooves and single bevel grooves are commonly used to allow access to the root of the joint.
On thicker members, double V-grooves offer the best protection against distortion, provided you have access to both sides of the joint, because you can alternate welds from side to side. They also have less overall area than a single V-groove, which means they require less filler metal.
U and J grooves are sometimes used on thicknesses 5/8 inch or greater. These joint designs help to minimize burn-through, and they provide good access to the root, along with narrower groove angles, which means less filler is required to fill the joint. But U and J grooves are expensive to prepare because they require machining. So designers weigh the potential savings in time and consumables against the cost of joint preparation.
The type of material also affects joint design. For example, stainless steel requires wider root openings, thinner root faces, and larger groove angles because it has a lower rate of thermal conductivity and different expansion characteristics than carbon steel.
Backing strips with runoff tabs are commonly used in FCAW to eliminate the need for root faces and to retain the fluid puddle in the joint. Groove angles can be steeper with backing strips because you can increase root openings to give better access to the root of the joint without causing problems like excessive penetration and burn-through.
Backing strips can be fusible or non-fusible. Fusible backing strips become part of the weldment, although they are sometimes removed after welding. Non-fusible backing strips may be fiber or ceramic and may be grooved to allow reinforcement at the root of the joint.
Flux core arc welding has several advantages, including high-quality weld deposits with a smooth, uniform appearance, the ability to weld a variety of steels at a wide range of thicknesses, high deposition rates and deposition efficiency, a higher tolerance for welding over contaminants and coatings compared to solid wire, reduced distortion compared to SMAW, and FCAW is more portable than GMAW when used with self-shielded electrodes.
However, flux core arc welding has some disadvantages too. FCAW is limited to welding ferrous metals and nickel-based alloys, such as carbon steels and stainless steels. It produces a slag coating that must be cleaned away. Electrodes for FCAW are more expensive than solid wire. The power source and wire feeder must be located fairly close to the welding operation, and FCAW produces more smoke and fumes compared to solid wire.